We're now going to move away from our basic power functions, and we're going to go look at exponential functions and logarithmic functions, the other two types that we have learned how to differentiate. So this first one you should know. So pause the video, write down what the antiderivative of e to the x is. And my guess is you probably wrote e to the x, but my question for you is how many of you remembered to include the constant of integration, that's c? If you forgot it, you got it wrong. That must be there every time you take this indefinite integral. And again, we'll find out what a definite integral is in just a bit. So now let's look at more complicated e. E to the ax plus b, e to the stuff, if you will. This looks an awful lot like chain rule, and we can integrate this using another one of these little u substitutions. We'll let u equal ax plus b, du is equal to a dx. So again, if we had times a here, we have to balance it with times 1 over a, and this becomes 1 over a times the integral of e to the u du, and we know that. The integral of e to the u du is just e to the u, plus c, of course. And then we replace the u with what it stood in for. We have 1 over a times e to the ax plus b plus our constant of integration. And this looks really similar to what happened with the power rule, which is sort of why textbooks tend to present that one way to do it theorem, if you will. But again, I like the u substitution because it's far more applicable to bigger, more fun functions later down the road. So let's do an example. We have the integral of the square root of e to the 5 minus 3x dx. There's some rewriting that needs to happen. I want you to pause the video and try to write this in a form that we can deal with. So we have the integral of e to the 5 minus 3x to the 1/2 dx, which is the integral of e to the 5/2 minus 3/2 x dx. And now we have this in a form where we can use a u substitution. I'm going to let u be 5/2 minus 3/2 x. du will be negative 3/2 dx. So I need a negative 3/2 multiplied there, which means to balance it out, I need a negative 2/3 out in front. So my integral is now negative 2/3 times the integral e to the u du. Again, that part became du. Negative 2/3 e to the u plus c. And making our substitution back in, we have negative 2/3 e to the 5/2 minus 3/2 x plus c. And there is our finished antiderivative of that function. And on to generic exponential functions. So any number to the x, remember e to the x and 2 to the x or 3 to the x or any other base behave a little differently when we differentiate. For instance, the derivative of 2 to the x is equal to 2 to the x times the natural log of 2, as the power times the natural log of the base would be our derivative. So I want to know what the antiderivative of 2 to the x is. So what I'm thinking is 2 to the x was the derivative of what? That's what antiderivative means. This 2 to the x is the derivative of what function? In other words, we're trying to go this way back to that thing. But 2 to the x isn't by itself over here, and that's easy to rectify. We have 1 over natural log 2 times our 2 to the x. Divide both sides by natural log 2. So the antiderivative of 2 to the x dx with respect to x is 1 over natural log 2 times 2 to to the x. And in general, the antiderivative, the integral of a to the x dx, is equal to 1 over the natural log of the base times a to the x plus our constant of integration, which I happen to forget up there. Please be careful with that. It's easy to leave off. And this, ladies and gents, the reason I'm presenting this to you and saying, here it is in all its glory, this is just a formula, it's in your formula book for IB. It's great stuff. Let's go on to logarithms. Well, you should be able to answer this first one. The integral of 1 over x dx, or the antiderivative of 1 over x with respect to x, is the natural log of x plus c. But remember, we can't take the log of negative numbers. We can't take a logarithm of negative numbers. So when we take the antiderivative of 1 over x dx, it becomes the natural log of absolute value x plus c. So I want to find this next integral of 3 over 1 minus 2x dx. Well, that looks similar to up here in that the x is in the denominator. So I'm seeing x in the denominator. I'm thinking this antiderivative is going to involve a natural log. Okay, so what do? Well, it's going to be a u substitution again. So we're letting u be where this x was, where that variable was. Remember, this is like chain rule. So u is equal to 1 minus 2x. du would be negative 2 dx. So I have a 3 times dx here, but I want a negative 2 times dx. So I'm just going to do that. Now that part becomes du. And to balance out, remember, 1 over negative 2. So negative 1/2 is a constant I have to multiply by. So this becomes negative 3/2. I'm going to take the coefficient out in front. 1 over u du. So this is negative 3/2 times the natural log of absolute value u plus c. And I finish off with my substitution. Negative 3/2 natural log of absolute value 1 minus 2x plus c. And there is our antiderivative. And that is where I shall leave you today. So we've figured out how to take the antiderivative of a power function. A power function with stuff in the base, so undoing the chain rule. We've looked at how to take the antiderivative of e to the x, a to the x, and something over x. And those are our basic functions that we will be finding antiderivatives for in various forms put together. Have a great, wonderful rest of your day.